Welcome to the NASA headquarters. I am NASA Administrator Jim Bridenstine, and as everybody in this room is aware, we are going to the moon by 2024, and we want it to be sustainable. In other words, we're going to be able to stay at the moon for long periods of time by 2028, and we're going to have in orbit around the moon a gateway. In other words, a permanent and reusable command module around the moon for 15 years. Ultimately, the goal is this. We're going to Mars. And in order to go to Mars, we have to use the moon as a proving ground. We need to learn how to live and work on the surface of another world for long periods of time. And in order to do that, friends, we need spacesuits. The Artemis generation is now revealing its spacesuits for our generation. Let's take a look at the spacesuits of the Artemis generation. So to be clear, Christine is wearing a spacesuit that will fit all of our astronauts when we go to the moon. And it is also true that we have with Christine Amy Ross, who is a spacesuit engineer, and we have Dustin Gomert, who is wearing not a spacesuit that we're going to have on the surface of the moon, but on the way to the vicinity of the moon. So these are our spacesuits for the Artemis generation. Amy, if you would share with us a little bit about how this design for the Artemis generation is maybe different than the design for the Apollo generation.
Sure, I'll be happy to do that. We've been working for a long time to build spacesuits that will do the job on the moon and going on to Mars. So basically, my job is to take a basketball, shape it like a human, keep them alive in a harsh environment, and give them the mobility to do their job. So one of the things we've looked at is trying to reduce the space here, make a smaller unit, display and control unit here, and get those shoulders to where she has a lot more mobility to move. So she's able to do a cross reach and get across the suit, as well as reach overhead, which they can't do today and couldn't do during the Apollo program. Then in addition to that, we also, because this is the first time we've gotten to build a suit specifically for a planetary surface, we have a lot more mobility in the lower torso. So we have a waist bearing, and we have 3 bearings on the legs, as well as a flexion extension joint here at the waist. And that gives Chris a lot of capability to move around and do whatever tasks we might need to do for science and maintenance on the planetary surface.
So just so everybody knows, Christine's spacesuit is under pressure right now. And that usually makes it very difficult to mobilize. And yet, what is she doing? She's moving around. If we remember the Apollo generation, you remember Neil Armstrong and Buzz Aldrin, they bunny hopped on the surface of the moon. Well, now we're actually going to be able to walk on the surface of the moon, which is very different than our suits of the past. So if you would, Amy, tell us a little bit about the thermal environment on the moon and how this suit is going to be helpful in that environment.
Yeah, we normally try to plan for a thermal environment that ranges from 250 degrees Fahrenheit to minus 250 degrees Fahrenheit, with some potentially colder spots in the south pole of the moon. And so we are looking at the materials and the thermal protection for this suit to keep our astronauts comfortable while they perform their job.
So you're saying that Christine in this suit would be able to be at plus 250 degrees Fahrenheit or at minus 250 degrees Fahrenheit in the exact same suit?
Yes, we can. And so for the moon, we're using materials that allow us to do that. And when we go to Mars, we're going to need a new insulation because that has an atmosphere in Mars, and our insulation depends on the vacuum of space right now.
Awesome. And then when we talk about the South Pole, which of course is the goal, we want to get to the South Pole of the moon. It's really cold. Are we going to need to make modifications to this spacesuit for the South Pole missions?
So one of the things we're looking at to go to the South Pole is if we need to design some specific thermal systems for the boots, some cover layers, and maybe some active heating to keep your toes warm.
So the goal is to get to where all of the water ice is. We know that water ice represents life support. In other words, it's air to breathe. It's also water to drink. It's also rocket fuel, and it's on the south pole of the moon. This is really amazing. I hope everybody understands the mobility of this suit is astonishing under that much pressure. So let's talk about the pressure. Another risk of being in deep space is the vacuum of space. So tell us, what kind of pressure is she under? Is it 100% oxygen, those kind of things?
Certainly. So this suit is designed to operate at 8 pounds per square inch of pressure. Like I said, a basketball is operated around 7 to 9 pounds per square inch of pressure. If you put your finger and your thumb together, and put it on your shoulder, there's about 14 pounds, 15 pounds worth of air pushing down on you right now. So it's a fairly heavy pressure. And then she needs to be able to move under that pressure. So we have to make the suit flexible under pressure. We use 100% oxygen because we're trying to protect the astronaut from decompression sickness. And so that high oxygen concentration and the high pressure then allows her to go out and do a spacewalk quickly and not have the bends, which is decompression sickness. And then we can bring the pressure down because we have a new technology in the life support system, the backpack, that allows her to come down to 4 pounds per square inch of pressure and have more flexibility in her gloves while she works.
And the gloves are key because your dexterity, show us if you can move your fingers. Can you move your... She can't hear us because she's in the vacuum right now. She's under pressure. Yeah, so that's really, really impressive. Okay, so another big challenge when we go to the moon is the lunar dust, which is extremely fine-grained and can be very damaging for spacesuits. And of course, we had to learn this for the first time in the Apollo program. So now we can take what we learned and apply it here. Tell us what we've learned and how we're doing things there.
Yeah, so my mentor worked on the Apollo suit, and 2 things I learned were zippers are bad and cables are bad. So we have no zippers and cables on this suit. What we have are bearings, so we can move easily in that pressurized suit. And what we need to do then is protect the bearings from the dust. And so we have seals in the bearings. We also are designing our environmental protection garment so that it helps mitigate the dust as well. There'll be fewer seams and new materials that keep the dust out.
That's fantastic. Let's give Christine a big hand. Oh, by the way, before we do that, she's going to show us how to pick up a rock, if she can handle it. And she can.
It's a heavy rock.
This is difficult to do in a spacesuit. All right. I got the rock. Thank you. Okay, so she's under pressure right now, and she could very well run out of air very shortly. So she's going to be exiting the stage, and we're going to bring up Dustin.
Do you want me to take the rock?
I'll also set it back down here. So Dustin is wearing a different type of spacesuit, and Amy, I guess Amy will come back a little later. But Dustin, tell us about the spacesuit you're wearing and how it's different than the spacesuit that we're going to wear on the surface of the moon.
Yes, sir. Good to be here. This suit is the Orion Crew Survival Suit. And so while the mission of that suit is to what we do when we're there, this is the suit that gets us there and gets us home safely. And so this suit is fully integrated with the vehicle from the ground up. So when it's tailored to the human body, it's also tailored to the seat. So we have 100% fit in the vehicle and 100% integration with the Orion ecosystem. So
when you say ECLIS for the audience.
Oh, yes, apologize. We speak in lots of acronyms. So yes, the
environmental control and life support systems.
Yes, sir.
Okay. Got it. Okay, so your suit is generally going to be depressurized, which gives you a lot of mobility, flexibility, and of course, when you're flying in deep space, you're going to be just fine without the pressure in the suit. Why would it need to be pressurized when you're in a pressurized capsule?
In a pressurized capsule, we don't necessarily have to be pressurized in this suit. There may be some future cases of decompression sickness mitigation that we might want to use it for, but the primary use is in the case of an accidental depressurization. We can take safe haven in this suit. We'll seek refuge in here. We'll keep the body at 8 psi for a certain period of time, and then we'll drop down to about 4.3 psi, and we can remain there for up to 6 days. And so that's no small feat to be able to live in a volume that's only a couple inches bigger than your body for 6 whole days.
So a lot of people, I think, it gets missed, and it gets missed by a lot of people at NASA, that spacesuits are more than suits. This is, in essence, when necessary, a spacecraft. And same as the space suits that we just saw for the XEMU, which is how we're going to walk on the surface of the moon, it is a personalized spacecraft for a person walking on the moon. In other words, So let's pretend you do have an unfortunate depressurization kind of situation. Maybe a meteorite impacted your vehicle, punched a hole in the capsule, you still got to get home. Now you've got a spacesuit that is providing all of your life support. That's the intent, right?
That's correct, sir.
So other than the life support, what parts of the mission will you be having? You'll be able to get out of this suit when you're in deep space.
That's correct. As soon as we get to orbit, the crew will nominally take the suit off. We talked about the word doffing this morning, which is to remove the suit. We'll stow it for the most of the mission, and we won't put it back on until it's time to come home. Once we get home, though, it's not just the suit that provides us safety in deep space. If we had a contingency on landing, the suit is designed for all the aspects of the post-landing safety for the crew as well.
So it has thermal protection?
It does have thermal protection, not the same as what the XEMU has, though, in terms of the radiation environment of space. But internally and under this suit, we'll wear garments to manage our thermal environment with liquid cooling.
Awesome. So I just want to say thank you to you, Dustin, another spacesuit engineer. Amy, who was just up here, spacesuit engineer. Christine, who was in the XEMU, which is the spacesuit that we're going to use to walk on the moon, also a spacesuit engineer. We have some really talented people. Remember this, we as the Artemis generation are building spacesuits that will fit all of our astronauts. We want every person who dreams of going into space to be able to say to themselves that yes, they have that opportunity. And that's what we're working on right now at NASA. With that, Bettina, I'll toss it over to you.
Thank you, Administrator. We're excited about this opportunity to talk about all of NASA's spacesuits and the next generation. We're going to turn it over to Cheryl Warner, who's in the lobby with Christine. Now she's depressurized her suit. We have some special guests who want to answer some questions.
Thank you, Bettina. Christine, that was an incredible demonstration of the Artemis generation spacesuit. How do you feel?
I feel great. The suit's built for mobility, so it's easy to move in, so I can be able to walk around easily and be able to do dynamic motions.
We have some local students here who would like to ask you a few questions. So, Kayeen, do you have a question for Chris?
Are you already working on Martian prototype spacesuits? And what would be the difference between the spacesuits that travel or explore on lunar environments whereas Martian environments?
That's a great question. We are already working on Martian spacesuits. Our focus is first to get the spacesuits to the lunar on 2024, so that way we can do our mission back to the moon and send the first woman and the next man to the lunar surface. And then we're getting ready to send spacesuits to Mars in the mid-2030s. We're doing an experiment on the Sherlock instrument on the Mars 2020 rover to help test our spacesuit materials and see how well they do on the Martian surface. The suits themselves will be very similar between lunar and Martian. We'll have different portable life support systems technology to keep the crew members happy and comfortable in their suits between the difference of lunar and Mars.
Antoinette, what's your question?
Spacesuits have changed a lot over the decades, but what would be the most significant change made to the new spacesuits compared to the older models?
That's a great question too. One of the biggest changes that we made with our spacesuits is we can fit a much larger range of astronauts. We can fit anywhere from the 1st percentile female to the 99th percentile male. In addition, our spacesuits are made for spacewalks, so we optimize the two different functions of a spacesuit. We have the Orion crew survival suit that keeps the crew members safe in the capsule, and then we have the Artemis XEMU spacesuit that's for EVAs for doing spacewalks on the surface of the moon.
Great. And final question from Edith.
Have you worn any suits before?
So I'm an advanced spacesuit engineer at Johnson Space Center. So it's my job to design and build and test spacesuits. I've got the opportunity to try different prototype advanced spacesuits like Z2 and Z2.5 and some of the other suits we've made to get ready for the XEMU, as well as our current spacesuit, the EMU that we're using right now on the International Space Station.
Well, thank you, Christine, and thank you to our students. Back to you, Bettina.
Thank you, Cheryl. Thank you to Christine, Cheryl, and the kids for these great questions. During the program, we'll be taking questions from members of the audience, students, and also from social media. Use the hashtag AskNASA. Right now, here in the auditorium, we have two additional guests joining the administrator, astronaut Kate Rubens and Chris Hansen, the manager of EVAs, or better known as the Spacewalk Office. So before we start with that panel discussion, on to the administrator for some initial remarks.
Well, thank you, Bettina. It's an honor to be on the stage with Kate Rubins and Chris Hansen. I wanted to kind of highlight why we're doing this. We are going to the moon in 2024, but we're doing it in a way that's never been done before. This time when we go to the moon, we're going sustainably. In other words, we're going to stay for long periods of time. We're also going to go with commercial partners and with international partners. When I say commercial partners, how we get access to the surface of the moon matters, and we're doing it in a way that's never been done before. Instead of NASA purchasing, owning, and operating the hardware that will take our astronauts from the Gateway, which is a space station in orbit around the moon, down to the from the Gateway, that space station in orbit around the moon, to get our astronauts from there down to the surface of the moon, we're going to be buying a service. And of course, our commercial partners, we're anticipating that they're going to put their own money forward for the purposes of getting customers that are not necessarily NASA. So we're really trying to open up the architecture in a way that's never been done before. So that gateway that will be in orbit around the moon is going to be maneuverable. It's going to enable us to get not just to the equatorial regions of the moon, which is what we did during the Apollo era, but also to the North Pole and to the South Pole. And the South Pole, of course, is what we think is probably the most valuable because that's where there's hundreds of millions of tons of water ice. So we want to go to the moon with commercial partners. We also want to go to the moon with international partners. So when we build an open architecture gateway in orbit around the moon, the way we do docking, the way we do communications and data, avionics, all of these things are going to be available to the public. Environmental control and life support systems, all available to the public online. What does that mean? That means if you're a private company and you want to do a mission to the surface of the moon, you could integrate into our open architecture. If you're a small country and you want to have missions to the surface of the moon, you can integrate into our open architecture. Maybe you're a scientist and you want to do astrophysics missions looking into deep space from the far side of the moon. You will have that opportunity on the gateway or using the gateway as a comm or data relay that otherwise would not be available. We are looking to do things in space that we've never been able to do before using the moon, ultimately creating the architecture that we can replicate at Mars. So we're going with commercial partners, international partners. We're going to utilize the resources of the moon, namely the water ice. The water ice is life support. It's also rocket fuel. And ultimately, we're going to take all of this knowledge from this architecture in orbit around the moon, and we're going to take it to Mars. And we think that that is possible in the mid-2030s. So I just want to say, Kate Rubins, thank you for being with us. And of course, so people know, Kate is a veteran astronaut of NASA. She has done one long-duration mission on the International Space Station and is a veteran of 2 spacewalks. Let me ask you, Kate, are you ready to go to the moon again?
Absolutely. Yeah, thank you very much. This is great to be here. And it's really fantastic to see these suits and to let everybody see the mobility and the functionality of these suits. This is a really big step up from the current suits that we're using on board the ISS that we did our 2 spacewalks in.
So tell me, when you look at the suit here compared to what you flew with on the ISS, obviously walking on the moon is different than floating in space. What are some of the big differences you see and some of the challenges?
Yeah, so I actually did a lot of the testing of the initial versions of this suit, and so got a chance to perform some of these activities underwater in our giant neutral buoyancy laboratory, and then compare those same sets of tasks with our current spacesuit. And let me tell you, there's a huge difference. So the mobility is one of the biggest things. The fact that these bearings kind of go in gives you that great shoulder mobility that you saw. And that's very important for things where we're doing geology tasks. If you need to pick up a rock, if you're examining something, if you're planting a scientific instrument, you need that upper torso mobility. In addition, we can walk around in it, and this is pretty important. When we're on ISS, the legs aren't very useful during a spacewalk. We're mostly just floating there. But obviously in the lunar environment, we're going to need to walk around, and the more mobility you have, the more tasks you can get done, the more science you can accomplish, the further you can go.
Absolutely. Chris, what are your thoughts? Comparatively, compared to other suits that you've been involved in the past, big differences and concerns that you may have going forward?
So as we've mentioned before, the current EMU really has been a beautiful machine. It's served us well really through the shuttle program, through the station program. It's worked really well, but it was designed to work in microgravity. Works great for supporting the space station, but when we go to other destinations, down to the surface of the moon, in orbit around the moon, on the way to Mars, the surface of Mars, we need a different suit. As Kate said, the legs aren't super useful on board space station, so we need to find a way to get the crew to move around. In addition to that, technology has changed a lot since we started working on these. These new suits have a lot of new technologies embedded in them. They're significantly more reliable than the EMU that we use today. They've got redundant parts in it, redundant components. There's a good example. The CO2 scrubbing system that we use today has a limited amount of CO2 that it can scrub, and once we're done with that, we have to end the EVA. This new suit continuously scrubs CO2, so it will no longer be a resource limitation going forward. So there's a lot of technology that we've infused into this new suit that we're excited to take to new destinations.
So when we think about beyond the XEMU suit, which we're going to use to walk on the moon, we have the suit that we're going to fly to get to the vicinity of the moon, and we need that to be ready, no kidding, maybe within even a year. Are we going to be ready within a year for that to do Artemis 1?
For sure. That's, again, Dustin's job is to make sure that that suit that he showed you a little bit earlier is ready to go. For us, it's challenging for us too. The moon in 2024 means we have to deliver those suits about a year earlier to get them to the surface of the moon. The advantage, though, is we've been working this technology of this new suit for really about the last decade. And 2 years ago, we made a decision to test this new suit on board the International Space Station. So about 2 years ago, we started building this suit that we're going to fly to the moon. So it was perfect timing when we set the goal of getting to the moon in 2024, that we're ready, and these suits were designed to go to the surface of the moon. So we've got a couple-year head start for that, so we will definitely be ready really by 23 to deliver the suits for a mission in 24.
Awesome. Well, Bettina, I'll toss it over to you for Q&A from the audience or anybody online who might have a question.
Thank you, Administrator. I know we have some students who are really eager to ask some questions. Do we have Vanessa?
So my question is, like, why now? Why are we, like, now building these suits? Like, why is there a sudden push? Like, I know you said that, like, you're relying on lots of new technology, so why didn't we wait till later when we have more technology? Or why not before if, like, there's really a need to do it now?
So I think I'll take a stab at that. Just so you know, there have been efforts in the past to go to the moon. In the early 90s, I should say in the mid-90s, we had what was called the Space Exploration Initiative. It was a return to the moon and then on to Mars. And then in the 2000s, we had the Vision for Space Exploration, which was a return to the moon and then on to Mars. In each of those cases, we were in a position where the ambition was not matched with budgets. We're in a different position today than we were then. And we have seen significant increases in our budget with bipartisan support in the House and the Senate and strong budget requests from the administration all at the same time. So I think we're in a good position now to actually accomplish the objectives that in fact been on NASA's radar for a long time. But it is also true, as you have correctly identified, technology advances quickly. And I would imagine that once we do Artemis 3, the first man, I should say the next man and the first woman on the south pole of the moon by 2024, I would imagine that what we're going to learn is going to result in upgrades to the suits. Just like any other spacecraft, again, a spacesuit is a spacecraft. I would imagine there will be continual upgrades as we learn more and more. Chris?
Yeah, that's a great lead in. This new suit, one of the things that's different about this suit is it's designed to be upgradable. A lot of you have looked inside of a computer. There's a device we call a motherboard that allows you to take components off and on as they get upgraded. This suit was designed to work exactly that way. So as technology gets better, we get smarter. This suit can be upgraded and it can be worked on in space by the astronauts. We won't have to take it all the way back to Earth on the ground to upgrade it and modify it. We'll be able to allow folks like Kate, who's not a trained technician, this suit's designed so that anybody can upgrade this suit as technology gets smarter and advances.
So it's modular.
Exactly, it is modular.
Great. We're going to take another student question. Victor?
How does a space suit protect astronauts from radiation?
Well, that's a great question. I'll tell you the best way to protect astronauts from radiation in deep space is to get them to the surface of other planetary bodies. A lot of people don't realize that when you land on the surface of the moon, you are in essence blocking the radiation coming from below you because the radiation doesn't go through the moon. That would be true on Mars as well. So that cuts the radiation down just by going to the surface. So I do think it's important that orbiting Mars would be fantastic. I think if we're going to be there for a couple of years, which is going to be necessary, and I say that, there could be ways that we could do a short duration stay on Mars, but it's going to require us to upgrade our propulsion systems. But if we did a long duration stay on Mars, it can't be in orbit. We've got to get to the surface. I would also say that on the surface of the moon or on the surface of Mars, getting underground. On the moon, for example, there are lava tubes that astronauts could go into and be protected from the radiation of deep space. Those don't exist when you're in orbit around the moon. But the suit itself, Chris, I'll let you talk about the radiation capabilities.
Yeah, you hit it exactly right. It's very difficult to make a spacesuit that protects you from the kind of radiation that is damaging long term. So really, as Jim said, the idea is to get out of that environment as quickly as you can into a safer place. The suit itself, the electronics in the suit have to be designed to deal with that radiation environment. We can do that. It's a little harder with the people. So like you said, the key is to get out of that environment as quickly as you can.
So as you're probably aware, the Lunar Reconnaissance Orbiter has been mapping the moon and doing a very good job for long periods of time. We need to take what we learn there, figure out where there are opportunities to get under the surface, and then that will enable us to stay for longer periods of time. And of course, that's true on Mars as well.
Great. We're going to take a question from social media. I have Sean Walker from Facebook who used the hashtag AskNASA. How much air is in the suit and how long can EVA last?
I think, Kate, what is your experience with how long an EVA can last?
Yeah, so there's a couple different things that currently limit our EVA capability on board ISS. One of them is the amount of air in the oxygen tanks, and we can have about 7 hours of air depending on how much the person's consuming. A big limiting consumable is actually our ability to scrub CO2, as Chris said. And so that's one of the very exciting things about the new technologies of this suit. We're using a lot of new technologies in this suit. And so some of these things like the variable pressure that Amy was talking about, that can help extend the duration of the EVA and help us get to work right away so we don't have to spend a lot of time pre-breathing and using up our consumables. Things like increased CO2 scrubbing capability, those are all things that are currently limitations to the capability of a spacewalk. We imagine that spacewalks are probably not going to last much more than 8 hours. It's like running a marathon or a weightlifting session at the gym, and you don't want to do that for too much more than 8 hours. So that's our plan for lunar surface. But one of the things, because this suit has so much flexibility and capability, you can do an EVA and then you can get back in the suit and do another EVA the next day, and you're not going to be real beat up about it.
Chris?
Yeah, so just to add, so the new suit has air tanks in it that will hopefully allow us to get up to 8 hours, like Kate said, and then we have an extra hour in there of contingency in case something happens and they're not by the lander and they need to get back to the lander. We've got about an extra hour of air in the suit. We'd like, as suit engineers, we'd like to make sure the limitation is the human inside, and the suit can do whatever the human is capable of, because that will ultimately always be our limitation.
So if you were to stay on the moon, Chris, for say 3 days, would you be able to regenerate your suit for you do say a 4-hour mission one day, then go back into the HAB module, and then do another spacewalk the next day, and then back into the HAB module, and then another space? How long can you do that?
Exactly, we can do that. The suit can do that for as long as you can bring consumables. We can recharge the air, we can recharge the batteries. Again, the limitation's probably the crew. How hard are they working, and can they come back day to day and continue to do EVAs? The suit can do it for as long really as the consumables that we bring with us allow.
Okay, so we got to bring consumables.
We got to bring air and power.
Yeah,
correct.
Good.
And water.
Excellent. So there's a lot of capability here that would enable us to stay on the moon for long periods of time.
Yeah. So thanks so much for information about EVA. And for those that don't know, EVA is spacewalks. So we'll be talking a lot about those in the next few days. We have another question from a student, Edith. Do you have Edith? Well, we'll take a question from the member of the audience. Anyone in the audience?
Hi, thank you. I am an educator, and my students who love space and NASA and have no idea about all of the jobs that are available, what advice would you give to them to make all of their NASA and space dreams come true?
All of the jobs available at NASA. So great question. What is it? USAjobs.gov? Is that where you go to get the jobs information? USA Jobs.
That's how I got my job.
There you go. There you go. Astronaut. USAjobs.gov. So I think there were some qualifications she might have had that were important. But to the point, absolutely. NASA has job openings even right now, and of course we would encourage people to apply. But it's also true that when we look at the future of space exploration, it's not just NASA. We are going to partner with commercial industry because we want them to have customers that are not NASA. We want to be, especially in low Earth orbit, we want to be one customer of many customers in a very robust commercial marketplace for human activity in low Earth orbit. So what we're looking to do, and we're using the International Space Station for this right now, we're looking at 2 lines of effort that could have significant breakthroughs for the commercialization of low Earth orbit. One is industrialized biomedicine. We can compound pharmaceuticals in a microgravity environment in a way that you cannot do on Earth. We are proving that we can print in 3 dimensions human organs that you cannot do on Earth. If you do it on Earth using adult stem cells, if you do it on Earth, the tissue just goes flat because of the gravity well. And of course, in order to combat that, you have to build a lattice structure for the tissue to grow around. But if you do it in a microgravity environment, you can actually do it in a way that doesn't require that lattice structure, which is tremendously positive. These are just a few of the amazing breakthroughs. I really think we are 3 to 7 years away from at least one major breakthrough that will result in the industrialization of low Earth orbit in a way where private capital will flow into habitation in low Earth orbit. In other words, commercial space stations. And what NASA has already done is we've invested in commercial resupply of the International Space Station, so those commercial habitats will have resupply capabilities. We have invested now in commercial crew, and in the first part of next year, we're going to once again launch American astronauts on American rockets from American soil for the first time since the retirement of the space shuttles in 2011. That's going to be a really positive development for our country, but it's going to be commercial. In other words, NASA doesn't purchase, own, and operate the hardware. We buy the service from commercial industry. And of course, we want to see a lot of robust commercial habitats in low Earth orbit as well. Ultimately, what that enables us to do is then take the resources that the taxpayers give us and go to the moon and onto Mars, always keeping an eye on commercialization even there. The goal here is to expand humanity further into space than ever before. And commercialization is a key component. I talked a lot about industrialized biomedicine. There's also a lot of advanced materials that are being developed. Z-bland. We talk about fiber optics that can be created in a very pristine way in a microgravity environment that you cannot do on Earth. And of course, that means that the fiber optics manufacturing, the business case could close to do manufacturing of fiber optics in space. We're looking at creating materials for, say, a retina. We can do retinal implants using materials that you can create in space that you cannot create in the gravity well of Earth. And what that means is that, look, if a retinal implant, if you've got a $75,000 reimbursement from Medicare for a retinal implant, the business case closes. And if you can take up a small box to the International Space Station with able to manufacture 1,000 retinal implants, there's a business case to be had there. And so people who have macular degeneration might not have to lose their eyesight. So we are using the space station for advanced materials and industrialized biomedicine, believing, and I really believe this, that we are 3 to 7 years away from a significant breakthrough that is going to result in capitalization and resources flowing into the space commerce industry. And when that happens, NASA will be able to do more, explore deeper. We will always be a customer in low Earth orbit. But what we want to see is a day where there's maybe 1,000 people like Kate Rubins that can fly into space, and even more. That's what we're looking to achieve, and commercialization is the way to do that. And NASA is helping build that. So I guess my point is to your students, usajobs.gov, but don't dismiss all of the great private sector development that's underway right now, because there's going to be a lot more opportunity for the future.
Can I get a quick plug in? So I have 3 children myself, so your question is really important to me. The one thing I want to do is promote STEM, science, technology, engineering, math. Not every job at NASA is STEM, but a lot of our jobs are. And the one message I want to give you, for those of you that saw Christine up here in the suit, she had a huge smile on her face. We don't sit around doing math problems. We do really fun things. We build fun tools and we go to fun places. Ask Kate. So I tell your kids, it's not too hard to do it. Any of you can do it if you're willing to work hard. So work hard, get in the STEM fields, and come join us in exploration.
Great information. Thank you so much. We're going to take a question from social media, and then we're going to go to Annika, one of our students, talking about STEM, to ask a little bit more about that. From Twitter, I know we talked about this a little bit more, but it's important to highlight. Jakira from Twitter says, with mobility being improved, do astronauts still have to bunny hop to move around the moon?
Yeah, so that's one of the advantages of the suit. We probably will see some kind of hopping motion because of the lower gravity environment on the lunar surface. And we actually try some of this out underwater in the pool, and I actually was part of a mission that NASA did that did a little bit of lunar gravity testing on the seafloor. And so you get a bit of a hopping motion. But because you are able to move your joints in a unique way with this new spacesuit, it'll be a much more natural walking motion. The other thing is that it gives you flexibility to do things like reach all the way down to the ground. And you can imagine, you saw Chris doing some squats up here, and she was smiling the whole time. She was enjoying it. You're going to have to do a lot of that kind of motion on the lunar surface. And if that's incredibly difficult, you can imagine that that would wear you out after 6 or 7 hours. And so the suit is built with the human in mind so that we can do all of these tasks and then wake up the next morning on the moon and do them all over again.
Fantastic. So do we have our students? I know there was one more question from our students. Great.
How does the portable life support system filter out CO2 when the astronaut exhales?
Oh, so let me take that one. So if we talk about the EMU, it uses a chemical called MEDOX that as they breathe through that, it actually takes that CO2 and chemically it keeps hold of it so it doesn't get out. So we actually take it out of the airstream. The problem is once that gets full, it won't take anymore, and the CO2 will pass on into the astronaut, into the rest of the suit, so that's not a good thing. So the new suit actually does something different. We actually have 2 different beds. One of them sucks up the CO2, and while it's busy doing that, the other one actually gets exposed to vacuum and heat, and we actually burn off CO2. And when it's done, it just switches over to the other one, and we just keep going back and forth, burning off the carbon dioxide into the vacuum of space. So we can keep doing that for as long as the suit is running.
Thank you. We're going to take a question from the audience. Oh. Sure.
Yeah, my question was actually about Mars, but let me bring it down to Moon 2024. How would it be broadcasting from the moon? Would it be like high definition, like we watch sports around the world, or would it still be fuzzy like before?
Oh, it'll be high definition. It'll be beautiful. It'll be the most beautiful imagery of the moon you've ever seen. And I can't wait until we have that happen. So the reality is, if you look at what you guys have been doing on the International Space Station, the imagery that we get back from the International Space Station is absolutely phenomenal. It's gorgeous. It's crystal clear. And I think we can take that technology all the way to the moon and have it be very successful.
And as we talk, so we use the International Space Station to test those things. So we've recently flown high-definition cameras to the space station that actually attach to the spacesuits. They're up there right now. The crew's a little busy this month, so we're not sure we're going to get them installed for the next few EVAs. But sometime in the next few months, you'll see some really high-definition images coming down from our spacewalkers as they do the spacewalks.
Fantastic. We're going to take another question for the audience over there.
On this side? Hi, I'm Caitlin Singham. I'm a systems engineering and biology student at the University of Maryland. And my question is that since we're using the moon as a testing ground for Mars, does the XEMU integrate planetary protection measures in order to ensure that explorers can successfully reconcile the goal of establishing a human presence on other planets with the scientific obligation to maintain the integrity of natural environments?
That's a hard question.
I like planetary protection. I'm a microbiologist by training, so I'll take this one. We are taking into account planetary protection, obviously, in all of NASA's designs. One of the really interesting things is to actually take that and turn it on its head and think about using the lunar surface as a test bed. We can use detection methods there to try to identify what our catalog of microorganisms is in this architecture of the suits. We're also doing these kinds of things on board the International Space Station. This is a really unique opportunity to see what the microbiome is of a closed space environment. And so all of the things that we learn on ISS and the lunar surface are really going to help us with our planetary protection goals when we go to Mars.
I would also say, and this is just the reality, we as humans we will leave microbes wherever we go. It's just the reality, and we can't avoid it. If we are going to Mars, we will leave microbes, and I want to say that while that is of concern and we need to mitigate it as much as possible, to the extent that microbes get outside the spacesuit or outside the spacecraft at Mars, I think they will live for maybe a matter of seconds because of the radiation environment and the thermal environment and the other challenges of deep space. So what I want to make sure we don't do is that we don't hinder our ability to explore with humankind further by being overprotective, and at the same time making sure that we are responsible stewards of deep space.
Well, that was a great question. We're going to take one more question from the audience.
Hi, my name is El Bogat. I am an employee at NASA headquarters in the Mars Exploration Program. My question is specific to what do you think are the biggest scientific questions that you'll be able to answer in the lunar vicinity and on the lunar surface, whether that's about planetary or solar system formation, about the origins of life. What do you think are the biggest scientific advancements that you're excited to make in this next generation of exploration?
I'll take it first, and then I'll hand it over. A couple of things. I'll tell you, here's what we know about the moon. It's covered in pot marks. And guess what? The moon and the Earth, we fly through the same piece of space all the time, and we've been doing it for billions of years. What does that mean? That means that the Earth has this very active geology, very active hydrosphere, very active atmosphere. And so when we find rare earth metals, those are not earth metals at all. Those are asteroid impacts from billions of years ago, and they're very trace when we find them because we do have this active geology, active hydrosphere, active atmosphere. The moon doesn't have that. And so whatever impacted the moon billions of years ago is today right where it was billions of years ago. And that would not include just asteroid impacts that can give us insight into the early solar system, but also subatomic charged particles from the sun. The regolith, the soil on the surface of the moon, which is, it very rarely changes except when impacted by meteorites. That capability of looking at the regolith and seeing what the early sun might have been like, I think is an important capability. So we can get great heliophysics from the surface of the moon. We can learn about the early solar system from the surface of the moon. And I'll tell you one thing that gets me even more excited is what you can do from the far side of the moon. So one of the missions that I'm very excited about right now that is kind of in its infancy is something called DAPPER. So from the far side of the moon, in orbit around the moon with DAPPER, we will be able to look back into deep space, I should say back into time, and actually see the universe before the first light of the universe. We think about the James Webb Space Telescope that's under development right now. That's going to be able to see the first light in the universe. But we're not just looking out into space, we're looking back into time. And then what DAPPER could do from the far side of the moon, where it's extremely quiet from an electromagnetic spectrum perspective, with DAPPER, you're going to be able to see even before the first light, what we call the dark ages of the universe, after the Big Bang and before light happened. It's gonna change how we see physics. It's gonna add to science books. It's gonna add to history books, and that mission is only going to be made possible because there's a comm relay around the moon called the Gateway, which is human-tended and will be able to be upgraded and updated all the time. So instead of a $500 million mission orbiting the moon for getting that deep space astrophysics capability, instead of a $500 million mission, we could do it for, say, $90 million. So in other words, we will be able to do more astrophysics than we've ever been able to do before using the far side of the moon, and not just with an orbiter that can see deep space from the far side of the moon in orbit, but also very low frequency antenna that we can place on the far side of the moon. Remember, the first light in the universe was, of course, in the wavelength of light. But the universe has expanded dramatically since then, which means those wavelengths have expanded. So now when we look in the very low frequency, extremely low frequency areas, we can actually see the first light in the universe from the far side of the moon on the surface of the moon. So I will say this, certainly there's a lot that we don't know about the moon. From 1969 all the way up until 2009, we believed the moon was bone dry. In 2009, for the first time, NASA discovered that there's hundreds of millions of tons of water ice on the south pole of the moon. There is a lot more about the moon that we don't know, a lot more that we need to know. And it is going to open up our knowledge of the sun, probably of the Earth, of other planets, of our solar system, and of astrophysics. It's an all-of-the-above capability, and it's a shame that we're not there right now making these discoveries. But now we're going to get there, and I'm very excited about it. And of course, these extravehicular mobility units, EMUs, are going to be critical to making it happen.
Great. Well, we have one last question from using the hashtag AskNASA. We have Jonathan Knowles from Facebook asks, are these suits made in the U.S.?
Are the suits made in the U.S.?
So it's a little more complicated to say the suit is made in any one place. We have suppliers really from all over. Pretty sure all our suppliers at this point are in the United States. We have commercial suppliers that provide parts of this suit all over the country, though. So they are made in the U.S., but they're made really in the entire U.S., all over the place. So yes.
Fantastic. Well, thank you so much. We're really excited about today's show. We're going to, with a big hand of applause, we're going to welcome back our spacesuit engineers,
right.
Dustin and Christine. Thank you so much. We're going to turn it over to the administrator. We have a very busy time here at NASA. We have spacewalks, we have going to the moon, we have lots of incredible activities, and we're going to have him wrap it up.
Awesome. Thank you, Bettina. I want to thank all of our engineers and our astronaut here. This is an exciting time for us. This is our generation. We think back in history. We love Apollo. We love the Apollo generation. We just celebrated 50 years of Apollo, and I was out on the National Mall. I saw literally 500,000 people descend on the National Mall to celebrate a historic, very positive achievement in the history of humanity. And I can tell you, as a former member of Congress, I've seen 500,000 people on the National Mall before, and they're never happy. In this case, I see all the congressional staffers laughing in the front row. In this case, they were all happy, and they were all celebrating this human achievement, which was landing on the moon for the first time in human history. As much as we love Apollo, in those days, all of our astronauts, they came from test pilot backgrounds and fighter pilot backgrounds, and in those days, there were no opportunities for women. Today, we have an extremely diverse, highly qualified astronaut corps that includes women, and they are extremely excited about going to the moon. And it just so happens that in Greek mythology, Apollo had a twin sister. And Apollo's twin sister, her name was Artemis. So this time when we go to the moon, we go with all of America under the name of Apollo's twin sister, Artemis. But one thing that is important to remember, and this cannot be overstated, what we are doing is difficult. It's challenging. And in fact, in some cases, it's dangerous. We do everything we can to mitigate risk. And these spacesuits and the new designs are a critically important part of making sure that we are mitigating as much risk as possible. But we cannot dismiss, as we go forward, that space is hard. And let's close with a video. We call it Space is Hard.
Space travel is hard and unforgiving. It's always been and always will be.
It's going to be hard. There's a new chance of death. Going in a little can through deep space, it's a very harsh environment.
We think you can come back, but nothing is certain.
There are all sorts of challenges we will face on deep space missions. Communication delays, radiation protection, isolation of the crew.
So it is not surprising that some would have us stay where we are.
There's never going to be zero risk. When you're breaking the bonds of gravity, that's just part of the deal.
And it is one of the great adventures of all time.
Okay, all flight controllers, go for landing. Retro, go. Fido, go. Guide, go.
That challenge is one that we're willing to accept.
Surgeon, go.
Man in his quest for knowledge cannot be deterred.
Space is not just a destination. It changes you forever.
It'll be tough, really tough, but we have the right people for the job.
We have pressed the qualities for success into system after system.
This country of the United States was not built by those who waited and rested.
Pushed our people past every failure we can dream up.
We have never been more ready to meet the unknown.
Through Artemis, we will once again explore beyond our world.
And we will succeed.